the hard part comes when they give you conditions to permute or to combine, right? So can I ask, what is your understanding of a permutation?
Arranging.
Yeah, it is an arrangement of. What about combination?
Selecting.
It is a selection. Not bad. Okay, so when then it comes to mind, right? How does arrangement and selection relate to math? Actually, we're not so much concerned about how we arrange, but we are more concerned about how much we arrange. So basically, we are doing a lot of counting with the arrangement and selection. Okay, that is one thing. So when it comes to counting, meaning to say, firstly, we counting count counting possible arrangement means what?
Mm. The like how many ways to put things together.
Yeah, and so what matters? What is the most important thing?
And
Order matters.
uh,
Okay, so the very important thing about permutation is that the order matters, and then obviously then counting for combinations, then order doesn't matter. Okay, that's pretty much it. So before we talk about permutation and combination, I think you'll be familiar with this also. You are introduced to the factorial. Okay, so can you tell me what does the factorial do?
I don't know explain that, but then for example, like you put 5 factorial, then you have to like multiply 5 for 3 to 1.
Mm. Meaning to say we are multiplying a number and every other numbers that are smaller than it up until 1. So if we were to describe it as a general formula, let's say n factorial, meaning to say we have n times n minus 1 times n minus 2 all the way until we get 1. Okay? Mm. Let's just try some sample questions. Let's say I have the values of 1, 2, 3, 4, A, B, and C. What is the total possible arrangement?
7
7 what?
factorial.
7 factorial is which is 5040. Okay, then let's try if the condition gives you the numbers must be next to each other.
7/4.
7 over 4.
The 2 is the factorial.
So you mean 7 factorial over 4 factorial? No. When you do 7 factorial over 4 factorial, basically you are trying to look for 7 times 6 times 5, because the rest you divide by 4 factorial already. But then how we gonna group the number together?
Mm.
Okay, so what we can do here is, if I have, let's just say an example of the arrangement, an example of a possible arrangement, let's say A and 1, 2, 3, 4, cause all the numbers together, and then B, C. If you look at it, how you can visualize the way of arrangement is we have one item here, and 2 more items at the back. So total got 4 items that you can rearrange. No matter how you arrange these 4 items, the numbers will confirm be together one right? So it's 4 factorial here. But then we're not done yet. Not done yet. Because the numbers here inside also can arrange. So it can be 1, 2, 3, 4. It can be 4, 3, 2, 1, and so on. Then how we arrange within this group? What's the calculation?
You just put like the P at like 4 P's.
You can do 4p something also, but then 4p what? If you want.
Uh, copy or copy for
Yeah, okay. Oh, wait, that was a guess. 4p4 also is 4 factorial actually,
yeah.
right? But then why 4p4 is because within the four positions you have, let's just say you don't look at this arrangement anymore because we already arranged the ABCs and the numbers. Now we are rearranging numbers only ma. Then just look at this as a separate question if you like the total possible arrangements like this one. Ah, very straightforward ma. They say that one total possible arrangement, then you just do 7 factorial. Then we are looking for total possible arrangements for numbers only. Then it's 4 factorial. Okay, answer? You can just give me the number if you calculate.
Five
Five,
seven seven.
576. Okay, good. Let's move on. Now, here's another condition. Numbers are together, letters also together. What is the total possible arrangement of this condition?
3 factorial times 4 factorial.
Times 4 factorial and
So 7.
no. Okay, look at it. I know where your 2 factorial comes from, right? It means you group the numbers and then the letters as a group. One group, two group. Okay, can. Then 4 factorial comes from you rearranging the numbers by itself. Then what's left?
3.
Yeah, you have to rearrange the alphabets also. So times 3 factorial. So anytime when don't look at the question and how to say don't look at the question and just think in your mind. You can always write it out. Then you can visualize already. Much easier. Okay, 2 factorial times 4 factorial times 3 factorial, I think it's 288. Okay, this is all about factorial, right? Cause how to say factorial and permutations very tightly related now. Cause 4 factorial is 4p4 and so on, right? But then the limitations of factorial is that you have to multiply all the way to 1 unless you divide. But then when permutation comes in already, then pretty much solves all the problem already lah. Right, let me give you a definition. Not definition, formula. Permutation is given by NPR. Formula is n factorial over n minus r factorial. It's just like the one that you say just now, 7 factorial minus 4 factorial. Then you meaning to say you just want to find for 7 times 5 times 6. And so on. Right? Whereby n is your set size or the total number of items in the sample, which is what the questions will normally give you lah. In total got 7 books, in total got 7 characters, and so on and so forth. R is your subset size, which is numbers of items to be arranged. So far, everything we have done in the previous question is like all 7 characters is arranged ma. So then that's why we only use factorial, we haven't used permutation yet. When we start to limit the things that we want to arrange already, then we start to use permutation. Okay.
But isn't R like the same as n now? Because it's both like a number.
It is the number, but obviously they have to mean different things one mah, right? Because N is everything you have, R is everything you need, something like that. No worries. The next example will be very informative. Okay, let's just say I have 6 digits. Let's say 1, 2, 4, 5, 7, 8. And from these 6 digits, I want to form 4-digit codes. And does not repeat. Okay, first let's just try to find total possible arrangement with no restrictions.
6 factorial.
Are you sure 6 factorial? I only want 4-digit number.
Oh yeah, 4 factorial.
4 factorial, how to say 4 factorial. Okay, what 4 factorial means, right, is that if you are looking for 4 digits, you are only giving yourself 4 options for the first empty slot, 3 options on the next, 2 options on the next, and then 1 option for the last. Right? Then means you are missing out on 2 more options, meaning to say you are under calculating already. Right? Okay, now we go back to the definition first. That's why knowing your N and R is important. Set size in this example, set size is the 6 digits that we have. Everything everything that we have, and then question is asking for 4, then meaning to say the items that we want is only 4. Then how we calculate for total possible arrangement?
So 64.
Okay, but it sounds like you are guessing.
A bit guessing.
Yeah, but then answer correct lah. Okay, let's just look at how we figure out it's 6p4. Okay, same thing. The universe is 6 numbers. What I mean universe is this one lah. Everything given is 6 digits. We want 4 digits, so we give ourselves 4 slots only. But then in those 4 slots, right, especially from the first option itself, we have 6 options. So we have option of 1, 2, 4, 5, and 7, 8. 6 options to choose. Choose. If I say 6 options to arrange for one. So let's just say I pick the number 2 here, right? Then I move on to the second empty slot. I have left with how many options?
5.
5. Okay, good. So I took 2, so I'm left with 1, 4, 5, 7, 8. Right. Now let's say I take the number 7. Third slot, how many options do I have left?
4.
Which is 1, 4, 5, and 8. 4 options left. Let's say I take the number 5. Last one, I think you know already, we are left with 3 options, 1, 4, and 8. Let's just say I take the number 8. Right? Can you see already, right? The number of options per slot is reducing by 1. Just like for our factorial is like 6 times 5 times 4 times 3. Basically, the permutation is the same thing as the factorial, but then now we are limiting it to 4 options. And then so we take 6p4. 6p4 really just means 6 times 5 times 4 times 3. Okay, let's continue first. Let's just say I give you a condition. This condition requires you to form the 4-digit numbers, begin with 2 and end with 8. So 4-digit numbers. If you want, just now we have 1, 2, 4, 5, 7, 8. If you want to refer.
6, 2,
No?
4p2.
Okay. Can you explain how you got 4p2?
Plus, total number we have is 6 months.
Mm-hmm.
But then the whole spots they see begin with 2 and end with 3. So we only have 4 options. So then the bottom one we got 2 to 6.
Okay, very good. 4p2 is 12. So basically, if you want to understand it even further, then you probably should know this one is 1p1 and 1p1. Meaning to say, you fix 2 as the beginning, so your only option is 2, and then you arrange it as 2. Your n and your r is also equal to 1. Same goes for the 8. Okay, good. Multiply. Let's move on. Same thing, 4-digit numbers from the 6 numbers we have. I want even numbers only.
3p4.
It's not, but can I know how you got 3p? Wait, 3p4? Your r, if you, let's see, if you put in calculator 3p4, you actually get math error. Your n must be bigger than your r, always.
The numbers can be repeated, right?
No. The no repetition applies for everything, for all. This standard also lah. Like normally, most question is like they don't allow repetition one. Or if they allow, it's harder for you actually.
But there's only three even numbers
Yeah, there is. Okay,
with the 4 spaces.
okay. Let's see. We have 4 slots. Here we want the last number to be even, so we are left with 3 options. So I think this is what you have gotten so far lah, right? Okay. Then let's just say I take the number 4. Then the rest, how many am I left with?
2.
Because, how to say, if you go back to this question, right? Initially, I got 6 options, I only arrange for 1, then I move on already. So every consecutive number, I only, I minus 1 option lah. Same thing goes for this question. I have 3 options, yes, but then I only arrange for 1. Then how many am I left with? Because the 8 and the 2 also can be here, 2, 8, let's say 5. Right? So you don't want to throw away the 8 and 2 if you just pick 4. Make sense?
Oh.
Then how many you are how many are you left with?
3.
No.
Ah.
Okay, then let's list it out. Total I have 1, 2, 4, 5, 7, 8 again. Here I got 3 options at first, okay? And then I pick 4. I pick the number 4. Can you list it out? What are the other numbers that I can use for the rest of the slots?
1,
1.
5,
Mm-hmm.
7, 8.
So how many have I left?
5.
5p what?
5p4.
Why 4?
Oh, 3.
5p3. Okay. Right. So the answer is okay. So this one, what's the calculation for this one before we continue?
3p1.
That's it. So the final calculation is 5p3 times 3p1. Any questions before we move on?
No.
Okay. Let's do one more condition. Next condition, same thing, 4-digit numbers, but must be more than 5,000.
Like when you put them together, it's more than 5,000.
Mm-hmm.
Oh. This one I don't know.
Mm-hmm. Okay, let me see how I can guide you. Okay, when we talk about, let's look at the previous question first. The previous question, we think even numbers. And then from there, we kind of can figure out an idea that our last number must be an even number, 2, 4, or 8. Okay, come back to this question. If a number must be more than 5,000, what is the one thing that we need to fix first?
I thought the Friday should be like 578.
Okay, good start. So in your first digit must be either 5, 7, or 8, right? So your 5,000s, your 7,000s, and your 8,000s, then can already. Nothing else is nothing else we want to consider already. Okay, then can we just find the calculations for this slot first? How much what's the calculation?
3P1.
3p1. So 3 arrange for 1. Now, let's look at the next 3 slots. How many numbers are we left to fill in these 3 slots? Let's say I pick the number 7. Then what is left?
5.
5 numbers. So it is 1, 2, 4, 5, and 8. Yeah, lor. And then what's the calculation for this one?
5P3.
5p3. Just think, right? Okay, NPR. N is all the options you have, and R is whatever you need. I have 5 options, I need 3 of them. So 5p3. If you think like that, then shouldn't be an issue lah. Okay. So final calculation is 3p1 times 5p3. Let's move on. Any questions? Okay. Final boss question. The 4-digit numbers must be more than 5,000 and is an even number. So there's 2 conditions here.
The even number has to be like the entire thing or just one dot.
Even number pretty much just means your last number must end with the even number. Because for any type of numbers, even though others are odd numbers, you still can divide by 2 one. Any number can divide by 2 means is a even number already.
3P1 times 5P2.
Not exactly. Do you have anything else you want to add after that?
1P1 versus 1.
Not exactly. Okay, before that, okay, do you want to try again before we discuss? Okay.
So that 3P1.
Okay, can you tell me the whole thing again?
3P1 times something in the middle, then 3P1.
No lah. Okay. Let's see. Let me see how I can put it together. Okay. Here's the really confusing part about this one. Okay. So if we look back at the previous 2 questions we have done before, we have done even numbers and we have also done more than 5,000, right? But if we look at it separately, okay, no, we have to look at it together. Numbers more than 5,000, just now we considered 5,000, 7,000, and 8,000. And then even numbers, we considered numbers ending with 2, 4, and 8. The really confusing part about this is that there is a possibility for 8 to repeat. Right, let's just say if you do here 3p1, here also you do 3p1, here you do 4p2, 8 confirm there, it will include the calculation where you have, let's say, 8 and then 7, 4. It will include calculations like this. Then your 8 is repeated, which is not what we want. In this case, we will have to separate it. We have to separate the case or the scenarios that allows this to happen. So what we can do is, how to say, let me see. I look at it in two scenarios where the number ends with 2 and 4 and also ending with 8. So here is what I've just done. From the conditions they give us, I fix two scenarios. To, how to say, to confirm, to lock where my number 8 is, right? Here, I'm technically also locking my number 8. It's just that I'm locking it out of the ending number. For this case, I'm locking it in the ending number. So far, so good. In this case, so after I have guided you up until here, do you want to try again? So right, what I want you, to make this more understandable, what I'm trying to tell you is in these 4-digit numbers, so I erase first. In these 4-digit numbers, my last two number, I just allow two options. Okay, then can you calculate for this one first?
EP1 times 2P1.
And then
And then
still got these two slots. Very easy one. Okay, if I choose here, let's say I choose one number 4, I pick one already. Here I choose 8. Okay, let's just say I choose 8 because here I have 5, 7, and 8. How many I have left for the middle two numbers?
3.
No.
4.
Then 4 what?
4P2.
That's it. Here is when I'm considering that the number does not end with 8. Confirm don't end with 8 because I limit myself to 2 and 4 only. Whether this one is 8 or not, I don't care because doesn't matter. Okay, then the other condition I set up just now was ending with 8, specifically 8 only. So here I have 4 slots again. Here confirm 8, so it's 1P1. Complete the calculations for me.
9P3.
No lah. Don't forget your this one still need to be okay. Here's the what?
More than 5,000.
Yes.
4P2.
Okay, 4P2 is here lah, but then the first one
3P1.
3P1. Are you sure it's 3P1?
What?
This one 3P1 I understand lah. This one
2P1.
yeah, 2P1. Why 2P1 first? Answer me.
Like 8 is used up.
So here we only have options of 5 and 7 to fill in. Okay. And then what? So here we calculate already 3P1 times, this one is 72. This one is 24. Then what is the final answer?
What?
Cause like how to say question is asking for the number of possible arrangement when more than 5,000 and even number. So there's technically only one value as the answer, the total possible arrangement. Here I calculate for 72 lah, which is ending with 2 and 4. When ending with 8, there's 24 possibilities. Then what's the final answer?
I just add them up.
Okay, adding them up is correct, but then you sound like you guess that answer.
Yeah, 96.
96. Yes. Why do we add them?
Because the first one didn't include it.
Yeah. So this is one of the scenarios. This is the other scenario that could happen, meaning to say this 4-digit number either end with 2 or 4 or it ends with 8. When you have n, then you multiply. When you have or, you add together. Got teach So this is the scenario where either ending with 2 and 4 or either ending with 8. That's why we add them together. They are separate cases that could happen. Okay, you need some time to take this down? Okay. Wow, so keng no need.
I take picture.
Oh, okay. If you want, I can send you also this note. Okay. Permutation for now is done. I think you definitely need some practice. If we have time, then we will do some practice question. But then now we're gonna move on to combinations first. The combination is given by NCR. Formula is n factorial over r factorial times n minus r factorial. Is this formula important? Yes, I think in your binomial topic it is, but for now we are not gonna talk about it first. Okay, same thing. N is your total number of objects or items in the set. R is the number of items to choose. That's it. Same thing. N is everything you have. R is everything you need. Okay? Let's just do some questions. Given that I have 8 people and they are going to split for 2 Grab cars. So meaning to say the car that they hail is got a driver inside already lah. That's what I mean. So 8 people, how do I do the calculations? How many total combinations are there if 8 people were to split for 4 Grab cars?
2 Grab cars.
Sorry, what do you say?
2 Grab cars.
Yeah, 2 Grab cars can fit 8 people already ma. No need to order extra. What?
Oh. 8C2.
8C2? No. Okay, it's not, okay. Maybe if I show you this question, it's confusing, but the idea is 8 people splitting 2 cars. Each car can carry 4 people. So each car you choose 4 people to sit ma. And so how do you split the 8 people? Actually, you don't say split the 8 people lah. Okay, in that case, can we just break it down first? For car 1, what is the combination? Like this lah. Like this will be easier to understand.
For C 1.
4C1.
4C4.
4C4. Okay, 4C4 is correct, but is for the second car lah. First car is how many?
4 person.
4 person. Come back to the definitions again. I have this many people, I choosing this many people. So before I need to call the second car, I'm calling the first car. Right? Before I call the second car, I have 8 people to fit in the first car. So what's C what?
8C.
It's C4. Yeah. The what then after that, right, how we got 4C4 is because after you choose 8, you've shoved them in the car already, you are left with 4 people. That's why your total objects is 4, and then you choose 4 more to shove inside the car. That's why 4C4.
Wow.
Wow.
Heavy.
How do I put this out? Okay, let's just see. 8C4 times 4C4 is 70. Okay, let's just move on to the next question. Let's just say completely different question. So I have 6 candies and they are distributed to 3 children. What is the total possible combinations? So let's just say all the 6 candies are different. Okay, to put it in a more understandable context, I have a bowl of candies. I have a bowl of 6 candies. There are 3 children that are going to pick these candies and they are going to evenly distribute them. So each of them will take 2. So just imagine one bowl of candy, every children pick 2. What is the possible combinations?
And this one is 6C2.
Okay.
Then second one 4C2.
Mm-hmm.
Then 4C2.
That's it. Final answer 6C2 times 4C2 times 2C2. Why? Why I don't use 6C2 plus 4C2 plus 2C2? Just to make sure you understand.
Because it means that only one of the children get.
Because if addition means or means either these children get 2 candies or that children or that children. When we say all 3 of them get, then it means multiply. Okay, what about this one? This one is interesting also. I have 10 students, and let's just say I'm going to choose 8 of them to participate on a competition. Sorry, choose at least 8 of them. This is important. Choose at least 8 of them to participate a competition. The question is basically I want you to calculate the total possible combinations of students that can participate in the competition.
10C3.
10C3? How do you get 10C3?
10 people in total. Then 3 personal statement.
No ma. Because, like I said again, if NCR, N is everything you have, R is everything you need. Because 3 is, if you say 3, that means it's something you don't need already. Then technically not correct. What do you need from the 10 people? 10 choose?
10 choose 8.
Yeah, 10 choose 8. This is one of the possibilities because we are looking for at least 8 students, meaning there's a possibility that there can be 9 students or 10 students. Then what?
Plus 10C9, then yeah,
10 C
10.
10. That's it. So here then will be very obvious you add them together. So here is where you will see you have to come up with the possible scenarios, right? Like the one for the permutation one, that one is legit a bit confusing lah. Because firstly, the previous question, you will have to notice first that the number 8 will repeat, then you will have to come up with two scenarios, two different possibilities to end the 4-digit number. Then here is the same thing also. If you notice that they are asking for at least 8, then you will realize that there can be 8 students or 9 students or 10 students to participate. Then there is 3 different scenarios that you have to calculate for. Okay. This one equals to 56. Okay, now let's move on. Another new question. I have 10 boys and 8 girls. I am supposed to choose 4 of them to, again, participate in something also lah. Right? Find the total number of combinations when there is no restrictions.
18C4.
18C4. So it really just dives back into the understanding of your NCR lor. Everything you have and then choosing everything you need. So you have 18 people and then you're choosing 4 of them. Moving on, let's say the number of girls in the team must be equal to the number of boys in the team. What is the total number of combinations?
8C2 times 10C2.
Good. So this is from the understanding that we want 2 girls and 2 boys to participate. So I have total of 8 girls to choose 2 girls, and I have a total of 10 boys to choose 2 boys. That's why. Okay, sounds like your combination is much stronger than permutation, which is also very common lah. Most students also like that one. Next question. Number of girls must be more than number of boys.
8C3 times 10C.
And
Plus. Oh, 8C4.
Yeah, I think, let me see something. Okay, 8C4 is enough. Because if for me, then I will write 10C0 lah, but then 10C0 is 1. So 8C4 times 1 is same thing. If you don't want to write also okay. That's it. I did not calculate for this, but this one is the most important one lah. Right, also, just a quick explanation. When we think about number of girls must be more than number of boys, meaning to say there's 2 scenarios also. One scenario is that you have 3 girls and 1 boy, the combination, and the next combination you could possibly have is 4 girls with 0 boys. That's why it's either this scenario or that, and that's why you add them together. I mean, first you find the combinations of these 2 separate ones, then add together. Okay, here is the final question. Again, it's the same question as 10 boys and 8 girls. But then here's the catch. One of the girl and one of the boy are cousins. Now, you are supposed to, again, choose 4 to participate some competition, but both cannot be chosen at the same time. It's a short sentence, but it means a lot. So, find total possible combinations to choose the children to participate.
I don't know.
Okay, let's discuss. So, for 10 boys and 8 girls with one girl and one boy as the cousin, what we can first visualize is we can look at it as 9 boys plus one boy cousin and 7 girls with one girl cousin. That is just to visualize lah. And then there is 3 different scenarios. Can you tell me what are the 3 scenarios based on both cannot be chosen at the same time?
The 9 boys will get the one girl cousin, then the 7 girls will get the one boy cousin.
Okay. Yes and no. Cause okay, the thing is, what you are saying is right now is you have let's just say one boy cousin, and then you say 7 girls ma. Then here you are limiting already. You're limiting yourself to 1 boy and 4 girls to participate. It can be 2 boys, 3 boys, 4 boys, doesn't matter. That's why that one is the no part. The yes part is, yeah, one of the scenario is we only allow the boy cousin to participate. Then the second scenario is we only allow the girl cousin to participate. What will be the third scenario?
None of them participate.
Yeah, both of them don't get to participate. Okay, then we do the calculations now. No cousins. Anti-cousins, yeah. Okay, let's move on to the calculations. If I only have the boy cousin, if I fix a position for the boy cousin, I am left with 3 other positions to fill in. How do I fill in that other 3 positions given that I do not consider the girl cousin?
7 C2.
Nope. Okay. Why C2? You have three space ma.
Oh yeah, 3.
But that is also not 7C3. Again, if you are using 7C3, meaning to say you are limiting yourself to choosing only the girls. 3 girls and 1 boy doesn't make sense. You want to allow the boys to participate also. So, what is the leftover number of children to choose 3 from?
16.
Yes, 16. So 16 comes from omitting or from fixing the boy's position and excluding the girl cousin. Okay. This is one of the scenarios. Second scenario is I fix the girl cousin go participate. And then I exclude the boy cousin. Same thing, what do I have left for the other 3 spaces?
Yeah, 16 also.
Yeah, 16C3 also.
Have trust issues.
Later we will add together. But then the last one is how? No girl cousin, no boy cousin.
16C4.
Yeah, 16C4 plus 16C4. Final answer you can calculate if you want, but here is the working. And that is the explanation. Okay. Yeah, I'll send you this later. I'll see you next week. We have homework. You have any questions for today's class? Okay, then we can dismiss. Bye bye.